Okay, so my second chance to get the best presentation. So we are, as TNO, we are also working in this project that is called Mopo. It's tools for energy system modeling. Basically, in short, what Mopo is trying to achieve is to get some repeatable, and you can configure some data pipelines, and also to reuse the models and stuff. You also have the an optimization model in this framework, and you have a, let's say, Spine Toolbox is a user interface that is really nice to make it easy for the users to use any kind of model. So this is kind of all the workflow that we have. So we have a Spine Toolbox, and we have different, in the pipeline, you can have different models that you can also develop your own, but in this case, this is a package for the electric vehicles, this is for building, and this is for creating new renewable profiles, and then you have an optimization problem, which is here in SpineOpt, this package. And this package is basically, so this is the workflow manager, the Spine Toolbox. The data pipeline is, let's say, you can add all these features in between, all these packages in between with the data. And then we have SpineOpt, which is the one that is based in JUMP, and get the results again. So this is a really nice way to see how all this works. SpineOpt is the one that is developing JUMP. This is a big consortia, so it's a lot of people from not only TNO, but here is a more wide spectrum. So we have also BTT, KU Leuven, KTH, UCD, EPRI, PBL, okay, different, you can see here. And we have academic and practical end users. So SpineOpt, which is the JUMP-based module that we have here. So it's a model generator. SpineOpt main goal is on community building. So the idea is to have a research audience. What we want is to have a broad community that can develop on the model. So the model has a, let's say, basic standard formulation for energy optimization. And the idea is, okay, bring some students to improve those formulations and work on these different analyses and test. So that's the idea of this module. So it has some nice things. For example, you can have it's investment and operation problems, so also energy. It has some modules also for doing the flexible temporal resolution. There are some things that you can see there are things that are also in the other project because we are working in both projects, so it's kind of having the features from both projects here, and also having different options to build the units, let's say the energy assets in this case. I will try to show here. So this is from the interface. I will show a little bit more of that. And you can see that you can have a gas network with 6-hour resolution. You have then a gas-fired power plant, and then you can have an electricity network that is with 30 minutes resolution for the COPF. So that kind of stuff is what allows you to do this package. Here you can also see, for example, in a more, let's say, easy way, but it's the same idea. You have the gas network, the electricity network. You have also different type of, for example, you can also have the emissions, also CO2 emissions, the NOx emissions, and also you can have inertia. So you can define different outputs from these units in your model. So since it's generic, you can use this for different nodes and different applications. So it has the temporal framework, also the stochastic framework, really basic, but it's there. Unique commitment, ramping and reserves, which is important for flexibility. Investment for now it's only 1 year, but we are working on multi-year investment. Also has the nice feature of user constraints, so you can define your own constraints in the model if there is a constraint that you want to test. Also, we have PTDF-based power flow, pressure-driven gas transfer, DCOPF, representative periods with seasonal storage. Again, we have this MGA, also the same stuff that we are doing in Tulipa. What here is tailored to the use of a SpineOpt. What we are trying to do with Tulipa is to make it as a generic package that everybody can use as long as you have a model jump. So that's the idea, to use this a little bit, take it out from here and put it in a more community, in a way that more people can use it and benefit from it. Bender's decomposition is also there. That's definitely something that it's really tailored, so that's possible to take it out. Multi-stage optimization also is there, and rolling horizon optimization. It's one of the other options that we have there. Okay, so some improvements that we have done in the code that I think it's interesting to share. We have here the issue, if you want to take a look. But for example, to solve faster in the rolling horizon, here in this issue, we were working with arrow.jl. So let's say it again. We were working with dictionaries, and that was slow to save. And then we switched to use arrow.jl, and then we improve a lot how we store and saving the results. So also part of the idea for coming here is also to share those kind of experience. So if you are experiencing with dictionaries saving the results is slow, give it a try, arrow.jl, and if you want to look what we did, it's there. I also have to mention Manuel Marin is one of the main developers so he is also is one of the persons that is working a lot with all these issues. Speeding up calculation with contingencies. Also, we were doing some pre-calculation. This will be something that now that we know that the parameter opt interface, maybe it was a workaround for that, because we were building the model every time. So we were just, okay, let's build a model and just try to use some kind of hacky parameter to just activate or deactivate the constraint. But now maybe we can even improve even further with the parameter opt interface, because it was trying to do the same thing. So yeah, thanks for that again, Joaquin, and all the people that were working there. Yeah, so this also nice, maybe ideas, solve dual LP problems in parallel. We solve this rolling horizon type of problem that we just start solving the full year, but then start 1 week, the next week, just going forward. And for example, when we use highs, we need to recalculate the dual variables. In fact, that's something that I need to ask for the people from highs. So yeah, this was an implementation that was okay. You can move forward. You can use one thread to calculate the dual and continue with another thread going with the optimization in the rolling. So decoupling this calculation of the duals. It's useful if you are using rolling horizon kind of stuff. So just mentioning if resembles with someone, nice. Yeah, also another thing, we use a lot here the rolling horizon feature. So of course, if you have a week, if you have 1 year, 52 weeks, and in the middle of that, it crashes, so you need to restart. So we were doing some improvements here to get restarting your model in the middle if something happened. I don't know, somebody just shut down the computer or whatever, then you can restart with some fancy tricks here. And yeah, this is reducing variable history. This was more to say, be aware of the memory. We were just having a lot of memory because we were going to need it. So creating a lot of variables that were not needed. I guess we are all aware of that, but because sometimes you say, okay, I need these past parameters, just try to be efficient in the way you create your variables. I guess we also more or less relate to that. But yeah, just a piece of advice. Spine Toolbox, very quickly. So this is the user interface. So you can see that it's really nice. You can just, like boxes, you can just start put the boxes in here in the canvas, and you start having all the data. All the data is in a nice interface that the user can define. So you can define the workflows, and you can have different scenarios. You can define different alternatives. So you can have 3D scenarios and 3 different alternatives. This is quite useful. You can have a base scenario, high cost, low cost, and then you can have different alternatives. Again, low, base, and high cost, or depending on what you want to do. So you can do several runs with these different, this could be, for example, demand, and this could be, for example, any other type of the cost of the technology. So I will just go quickly here. It's just how we create this database, but I think it's maybe for the sake of time. It's based on entity classes, basically, and we can relate to entity classes in the database, and that's how we manage all the data in the system. So the idea is to try to enable this, try to enable different transformers to get to different models, but get a nice interface that you can have this interoperable energy system data, and they go to different tools, and then you can perform different studies. So Spine Toolbox is trying to achieve this type of goal. And that's Mopo. That's a project.